Welcome to Python, California Housing Price Prediction. In this lesson, you will learn the basics of Python while working on a real-world problem predicting California house prices. You will start from the very beginning and finish with a simple mini-project. Let us get started. Running the cell now. Ready to learn some Python? Let us begin. Sometimes, warnings appear in Python notebooks. Here is how we silence them to keep our work clear. We begin with a comment that tells us our goal. Now we import the warnings library, which helps us manage warning messages. This line tells Python to ignore all warning messages. That way, errors do not distract us. Running the cell now. Practice, try changing the comment and running the cell again. What is Python? Python is a beginner-friendly programming language. It lets you solve real problems with just a few lines of code. Today, you will use it for data analysis and prediction. Running the cell now. Let us see a simple example of Python code and comments. A comment is any line that starts with a hash symbol. Python skips these lines. This is another comment. It can help you remember what your code does. This line prints a message to the screen. Print lets you show information in Python. Running the cell now. Try changing the message in the print function and run this cell again. Variables in Python. A variable stores information. You assign a value with equal sign. Example, price equals 350,000. Running the cell now. Here we create and use variables in Python. This comment explains what we will do. Location stores a word or string of text. Median price stores a number. Is expensive use is true. True is a special value in Python for yes answers. Print shows all the variable values at once. Running the cell now. Change one of the values and see what happens. Python lets us do math with variables easily. Here is a comment to tell us what we are doing. We start by storing a home's price in A. We store another price in B. Now we add A and B and store the result in total. The average is total divided by 2. We print the total so we can see the result. Now we print the average price. Running the cell now. Try with different prices and watch the average change. Lists help store multiple items. A list is a collection of values stored in one place. You make a list with square brackets. Example, prices equals 450,000, 500,000, 530,000. Running the cell now. Lists are useful for keeping track of more than one value, like house prices. This comment tells us what we are about to do. We make a list named prices with 4 numbers. Printing the list shows us all the numbers inside it. This comment tells us how to see the first item in a list. Lists start counting at 0, so prices 0 shows 330,000. Running the cell now. Change one price and print the list again. Lists are not just for numbers. We can use them to track names of cities too. This comment tells us we are storing text in a list. Cities contains names of 3 California cities. Printing the list shows all cities together. This comment reminds us we can look at single items. -1 gives us the last item. So this prints San Jose. Running the cell now. Try adding another city to your list. Sometimes we make mistakes, like typing the wrong position in a list. Here is how we handle that safely. This comment explains what we will do next. The try statement sets up safe code. If something goes wrong, Python will not crash. We try to print an item at position 5. But our list has only 3 cities. If this mistake happens, except runs instead. This message prints if we tried an index that is not there. Running the cell now. Practice, what happens if you use index 2? Try removing the try block. The California housing dataset. You will use real data about California homes. This dataset helps predict median house values in different areas. Let us load the data and take a quick look. Running the cell now. Now we will load a real-world dataset for our project. This comment states that we are setting up data. We use a helper from scikit-learn to get California housing data. We import pandas, a tool for working with tables. We fetch the housing data and ask for it as a frame or table. This line stores the data in df, a short name for data frame. Printing shape tells us the number of rows and columns. Head shows us the first few lines so we can understand what it looks like. Running the cell now. Try printing df.tail to see the last 5 rows. Data tables have columns or fields. Let us see what kinds of data we have. This comment sets up the question we will answer. Here we print the names of all the columns in our dataset. These tell us what information we have for each row. Running the cell now. Pick one column and try printing its values with df, column_name. Sometimes real-world data has missing values. Let us check. This comment tells us to check for problems in the data. Here we check for missing, or null, values for each column. If any values are not counted, we will see a number higher than 0. Running the cell now. We can quickly see trends with statistics like the average. Here we explain our goal in a comment. This line calculates the mean, or average, of all the house values. Now we print the average value so we can see what most houses might cost. Running the cell now. Change a med house val to another column and try again. We can find homes above a certain price by filtering our data. The comment explains our filter goal. Here, we create a new table that only shows homes with a value greater than 3 million. This line prints how many areas match that filter. We look at the top few results to see which areas are included. Running the cell now. Try changing the price limit and rerun. We can create new columns to add new information to our table. Here is a comment explaining we want to add new calculations. This line creates a column called value per room by dividing house value by average rooms per house. Now we print columns for house value, average rooms, and our new calculation. Running the cell now. Make your own column for price per household. Sometimes we need to remove columns to clean up our data. This comment explains that we are deleting a column. This line deletes the column named value per room from our table. This shows us false if the column was deleted correctly. Running the cell now. A for loop helps us repeat actions for each value. Our comment describes what we will loop through. We take the first 5 house values and put them in values. Now, for each value, we move inside the loop and print it. Each value is printed separately. Running the cell now. Try using another column. List comprehensions offer a quick way to create new lists. The comment tells us what we will do with our list. We start with 3 simple numbers. This line makes a new list where each number is doubled. We print the result so we can see doubled values. Running the cell now. Practice, change 1, 2, 3 in nums and see the doubles. Sorting helps us organize our data in order. The comment shows that we aim to sort our table. We make a new table that sorts all values from lowest to highest by median house value. This prints only the house value column at the top after sorting. Running the cell now. Try sorting by Arve rooms. The zip function helps us pair up two lists, like city names and their values. The comment tells us we will combine lists. We start with a list of sample city names. We add a list of sample values, such as house values. Here is our for loop. Zip lines up each city with one value. Inside the loop, we print the name and its value together. Running the cell now. Try changing the values in each list and run again. Let us use input to make a simple prediction by asking a question. The comment explains we will collect user input. Input lets us type a number for average rooms. In changes it from text to a number. Here we make a simple prediction by multiplying by 65,000. We print the result to see our prediction. Running the cell now. Try entering different room counts. If you like this project, subscribe for more Python videos. Now we begin our mini project, training a model to predict home prices. A comment sets our purpose for this block. We import train test split. This tool lets us divide our data into training and testing parts. X is all our columns except the one we want to predict. Y is just the house value column. This line splits the information into training data and testing data. 80% is for training, and 20% is for testing. Now we print the sizes so we know our split worked. Running the cell now. Now let us train a simple model to make predictions. The comment shows this is part 2 of our mini project. We import linear regression, a basic way to predict numbers. Here we create a model and call it model. Now we train the model with our training data. Next, we predict prices using the data the model has not seen. We print the first 5 predictions to check what the model thinks. Running the cell now. Try running the cell several times to see the results. Let us see how well our model predicts by checking the error. This comment explains we are checking the model's quality. We import a tool that measures the model's error, called mean squared error. We import numpy as NP. Error is calculated using predicted and real prices. Using squared equals false means we get the root mean squared error. Now we print the error value. Lower numbers mean better predictions. Running the cell now. Try changing the test size in splitting to see if it affects error. When you use a model, your column names must always match. Here we see what happens if they do not. A comment introduces the troubleshooting scenario. Try tells Python to watch for errors. Here we remove a column and try to use the model for prediction. This is not allowed. If there is a problem, except catches the error. This line explains what went wrong instead of crashing. Running the cell now. Practice, try predicting with only the right columns included. We often want to quickly understand our dataset. The describe command is great for summaries. Our comment explains what describe does. This line prints summary statistics for every numeric column. We get counts, averages, and more with just one command. Running the cell now. Try using describe on a single column, df, Arve rooms, .describe. Let us predict a house value for data you make up. Try changing the numbers and run again. The comment sets the stage for a new prediction example. We start a dictionary to hold our house details. We give the median income as 6. House age is 30 years. Average rooms is 8. Average bedrooms is 1. Population for this area is 100. Average number of people per house is 2. Latitude gives the location north and south. Longitude gives the location east and west. We turn our dictionary into a minitable for prediction. Finally, we predict the value for this made-up house. Running the cell now. Try making a mansion by increasing the number of rooms. Lesson recap. You learned Python basics and used real data to make predictions. Great job making it to the end. Ready for more? Practice by changing numbers and running cells again. Running the cell now. Thanks for following along. If you enjoyed this lesson, like, subscribe, and share. Let us know in the comments which project you want next. Happy coding! Running the cell now.